Hello viewers, I'm Kausalya. Today we are going to solve second problem in finding y parameters. So here the problem is find the y parameters for the network shown in figure, and this is the given network. We have two ports. One is input port and another one is output port. And I1 and I2 are the respective currents flowing through the input port and output port. So here the basic equation for admittance parameters are I1 is equal to y11 v1 plus y12 v2 and I2 is equal to y21 v1 plus y22 v2. So as a first step, now we are going to short circuit the output port, and so here the output port is B dash. So I am going to short circuit this. Once this port is short circuited, what about the voltage existing there? The voltage will be 0. So let V1 be the voltage at the input port and V2 be the voltage at the output port. Now I had short circuited the output port. So automatically the value of V2 will be equal to 0. So here after short circuiting, this is the circuit diagram. How it is? Because you see here, once this side is short circuited, automatically the current flowing through this path, it won't enter the 4 ohm and it will flow through this short circuit path. Why? Because the current will always select the least resistance path or zero resistance path. Therefore, when this port is short circuited, this 4 ohm resistor won't comes into picture. Right, that is the 4 ohm resistor will be removed or it is neglected. So here this is how the circuit diagram will be when this port, when this port B dash is short circuited. So we will be having only 3 resistors and the resistor of 4 ohm is neglected. So here when you look at these equations, when V2 is made 0, obviously these two terms will be 0. So now we are going to find the values y11 and y21. So here you see what is the expression for y11? It is I1 by V1. So here you see I1 is nothing but y11 V1 and y11 is given by I1 by V1. So now we are going to find the value of V1, right? So this is the voltage V1. So V1 is nothing but I1 into Z. So now we are going to find the impedance of the circuit. So here you see the current will flow like this. You see here we have short circuited this port. So here the only existing available voltage is V1 and the respective current is I1. So you have to proceed this way. So how to find the impedance here? You see the current I1, once it reaches this node, it gets divided into 2. What does this mean? These two resistors are parallelly connected and that combination is in series with this 1 ohm resistor. So here you see V1 is equal to I1 into the value of effective impedance is given by these two resistors are connected in parallel. So 2 into 2 divided by 2 plus 2 and that combination comes in series with this 1 ohm. Therefore here it is 1 plus. So once you solve, you see 2 into 2 is 4 and again 2 plus 2 is 4. So this becomes 1. So 1 plus 1 makes 2. So here finally the value of V1 is equal to 2I1. But what we actually need? We need I1 by V1. So just we are going to rearrange the expression. That is V1 is equal to 2I1 but I need I1 by V1. So I1 by V1 is nothing but, here we are substituting, in both the ways it is correct. So here you see y11 is given by the ratio I1 by V1. Now V1 is given as 2I1. So these two terms cancel and here we are ending up with 1 by 2 which is nothing but 0.5. So here the value of y11 is 0.5 mho or Siemens. Right? Now we are going to find the next term. So here again when you look at the base equation, now we are going to make this V2 0. So we are going to find the value y21. Therefore here the expression is, you see I2 is equal to y21 V1. So y21 is I2 by V1. So now we are going to find the value of I2 from the same circuit. So here, this is our circuit diagram, and now we are going to find the I2. So now current division rule is applied here. So I2 is this one, right? So I2 and I1 are opposite in directions. Therefore, I2 is equal to, here the total current is I1. I1 multiplied by opposite resistance. What is the resistance which is opposite to this I2? Because we are going to calculate I2. Wait, let me write. Here I2 is equal to, the total current is I1 and the direction is opposite. Therefore, minus I1 into, what is the opposite resistance for the current I2? It is 2. Therefore, 2 divided by what is the total resistance? Here the total resistance is 2 plus 2. So, 2 plus 2, which is 4. Right. So, here you see I2 is given by minus I1 into 2 divided by 2 plus 2. So once you solve, this becomes 2 by 4 and here it is 1 by 2, and here we are having a minus. So finally the I2 is given by minus 0.5 of I1. So we have calculated I2. So in this ratio, that is Y21 is given by I2 by V1, and now we have calculated the value of I2, and V1 we had already calculated previously. So just substitute these values here. So once you substitute here, you see again the term I1 will be cancelling each other, and minus 0.5 by 2 gives the answer minus 0.25 mho. So this is the value of Y21. That is, by short circuiting the output port or making V2 as 0, we have calculated Y11 and Y21. Now we are going to find the remaining two parameters. For that, we have short circuited the input port A dash. Right. So, and here we have a supply voltage of V2, and I2 is the current that flows through this port, and here I1 is the current like this. Now we are going to find the value of Y22. So Y22 is nothing but it is the ratio of I2 by V2, and now we are going to calculate the value of V2. So here V2 is nothing but I2 into Z equivalent. So now you have to look this circuit diagram from this side, that is from the direction of I2. So when you look like this, you see I2, when it enters this node, it gets divided into 2. And again when it reaches this node, it gets divided into 2. Right? So here the first thing is, what do you mean by when the current divide? When the current divides, this means that these two resistors are parallelly connected. So here you see 2 ohm is in parallel with 1 ohm. So when you solve here, we get the answer 2 by 3. And this combination is now in series with this 2 ohm, right? So you see this 2 by 3 ohm is in series with 2 ohm. So just we have to add. So 2 by 3 plus 2, once you take LCM, here we are finally ending up with 8 by 3 ohm. Now you see we have simplified this and we have added with this. Now again this combination is in parallel with this 4 ohm. So 8 by 3 ohm is parallel with this 4 ohm, and again when you calculate the Z equivalent, you see the formula is Z1 into Z2 divided by Z1 plus Z2. So just substitute the values, and here you see the denominator terms, they cancel each other, and finally we are having 32 by 20. Once you solve, here the answer is 8 by 5 ohms. Right. So we have calculated Z equivalent. So V2 is equal to I2 into Z equivalent. Now we have calculated this value, so you can substitute it over here. So you see V2 is equal to I2 into Z equivalent is 8 by 5. But what we actually need, we need the ratio of V2 by I2. Right. Sorry, here we need the ratio of I2 by V2. Right. Even you can directly omit these terms. Unknowingly I have calculated the impedance, then I had taken the reciprocal. You can directly go by this. We need the ratio of I2 by V2. So here is I2, I am moving this V2 here. So I can move this 8 by 5 to the left hand side. So here it becomes 5 by 8 more. Okay, you can do it directly. No need of this impedance and all. Right. So we have calculated y22. Now we are going to calculate y12. So this is our final parameter to be calculated. So here you see I1 is given by y12 V2 and we need to find y12. So y12 is given by I1 by V2 provided V1 is short circuited. So here the calculation of this you have to listen carefully. So again we have to go back to the circuit diagram. So for finding I1 we are doing these steps, right? So here you see this is the current I2 and here in order to make our calculation simpler we are taking a new term I2 dash. Let this is the current flowing through this 2 ohm and here I1 is the current as usual. So I1 here, I2 here and here we have introduced a new current I2 dash, right? Now as a first step, I am going to calculate the I2 dash. So how to calculate the I2 dash? Again, we are going to apply the current division rule. So to calculate I2 dash, here what is the total current? Here the total current is I2. Right. So here I am sorry. You see, this is the direction of our I2 dash. Right. And this is our I2. So to find the value of I2 dash, what is the total current? Here the total current is I2 because here we are having a source voltage V2 and that produces the current I2 and I1 is the short circuit current. Okay. So we have to consider only the current that is produced by the source. So here this is I2 and this is I2 dash, the current flowing through this 2 ohm. So the I2 dash is nothing but the total current is I2 multiplied by opposite resistance divided by total resistance. So here in this case the opposite resistance here is 4 ohm, right, divided by the total resistance. Here the total resistance include all these things, all these 4. So here you see these two resistors are parallelly connected, right, and that is that comes in combination with these two. So here the opposite resistance to this current I2 dash is 4 divided by total resistance. Here the total resistance include 4 plus 2 plus the combination of these two. So here these two are parallelly connected. So once you solve, what will be the answer? The answer will be 2 into 1 divided by 2 plus 1, which means 2 by 3. Therefore, and here the direction of current I2 and I2 dash are opposite, right? So here it is minus I2 into opposite resistance is 4 divided by total resistance, right? 4 plus 2 plus the parallel combination of 1 and 2. So here as a next step we are going to take LCM. So once LCM is taken, you see finally here we end up with the answer as I2 dash is equal to minus I2 into 3 by 5. So we have calculated I2 dash. Now we are going to calculate I1. So here I1. So I1 is nothing but, we need to find I1. So I1 is nothing but I2 dash, right? Because this is the current that flows here. So I2 dash into, what is the resistance which is opposite to I1 here? It is 2 divided by the total resistance is 2 plus 1. Right? So here the value of I1 is nothing but I2 dash. It is plus I2 dash because I1 and I2 dash are in the same direction into opposite resistance is 2 and the total resistance is 3. So what is the value of I2 dash? So I2 dash is nothing but minus I2 into 3 by 5. So just substitute the values here and once you solve here we are ending up with the answer I1 is equal to minus I2 into 2 by 5. So finally, the value of Y12 is given by I1 by V2. So what is I1? I1 is I2 into 2 by 5. And what is V2? V2 we had just calculated in the previous parameter, right? So here it is I2 into 8 by 5. So once you solve here, we end up with the answer minus 1 by 4, which is nothing but minus 0.25 mho. So finally we have calculated all the 4 parameters. That's all. If you have any doubt, let me know in the comment section. Thank you.